this video, we're going to be continuing our doctor's office example that we did in the last video, making an XML document to represent patients, and we're going to be creating a schema for this XML document. It's really important that before watching this video, you watch my XML example video. This video is going to contain that XML example from that video, and we're going to be carrying on with creating a schema, or sort of a blueprint for that XML document. So if you haven't already watched it, check that video out. If you haven't yet, you should also check out those XML tutorial slides and that XSD XML schema tutorial slides, because they'll give you a lot of the background in XML and schemas. And in this video, we're going to be putting that into practice with a doctor's office example that we saw in the XML example video. Also, I've mentioned it a few times now, but I do highly recommend the W3 School tutorials. They're optional, but they will give you sort of some extra content, some extra resources, if you feel like you're struggling with XML or XML schemas. They have some interactive quizzes and some interactive tools, so they're really great, and I do recommend you check those out, either as part of your studying, or as part of sort of just to brush up on your XML, if you feel that the content we've provided isn't quite enough, or you'd just like it presented in another way. So let's get started on a quick review of XML schemas. So before we get into the example, we're going to start by giving a quick review over XSD, which is the XML schema format. So XSD, or XML schema definition, is trying to solve a problem. And that problem is also part of the solution that XML offers. So the XML syntax is very flexible and very extensible. This is good. It allows us to store all kinds of data. We can store health records in the same format that we can store access control policies, in the same format that we can store like patients for our doctor's office in this example, or a friends list as we saw in the slide example. This comes with a problem. Not all these documents are going to be the same. We need some way to standardize in between these documents. If we're making health records, we probably want to make sure everyone's using the same element names and everyone understands what can be stored in those elements correctly. So we need some way to provide more standardization. We also need a way to help reduce logical errors. Remember that XML validation step we did in the last tutorial was only checking for XML syntax errors. So we want to check if things aren't so logically correct, if the wrong types of values are being stored in elements, for example. So as one example, we saw this sort of error come up in the XML document when we tried the one with errors that you can get on OWL. One of those errors was that we had both a doctor ID and a physician ID as the element name in the same file. So how could we stop someone else when they're trying to represent the same data using physician ID instead of doctor ID? There's a lot of room for confusion there. Both would be valid XML syntax, assuming they closed it with the same name, unlike in our error example, but they could be slightly different documents. So we need a way to enforce our specification. So XSD is a solution for that. It itself is an XML document, but the data that this XML document is going to hold is going to be the format of another XML document. So it's going to be a specification for another XML document. So the kind of things an XSD document would store would be what kind of elements are allowed in the document, the names of those elements, the element types. So is doctor ID a simple element? Is it a complex element? Remember, simple element is an element that only holds data, while a complex element is one that can hold other elements. It also can enforce the order of elements in your file, the number of occurrences of those elements, and what kind of type of data they can store. Can this element store like an integer for doctor ID? Can it store a string, maybe for like patient address or patient name? Or can it store a date, like the patient's birth date? It can also restrict what kind of attributes these elements can have. If you recall, attributes are usually what we use for metadata. In our example from last video, we had one called last update that said when the medication list was last updated. So what does XSD use to do? Well, we've kind of hinted on that a bit, but it provides instructions to others how to create and format their XML document. It provides a way to validate XML documents that have been made by others to see if they conform to our standardization. For example, we might have a marketing intern that we're giving a specification to and say, make this patient list or make this supplier list. We want to see if they did it correctly, if it conforms to our specification. So we can use XSD documents to sort of automate that check. It also helps to explain and describe our XML document. This describes what kind of data can be stored in each element, how many times those elements can occur, and other things like that. So when we just made that XML document in that last example, you could sort of guess at a few things just by looking at the data, but we really don't know like how many times a medication can occur in a medication list. Can the maximum be 3? We only saw an example that went up to 3 medications. Is the minimum 1? We saw the least being 1. Can a patient have no medications? Can they have an unlimited amount of medications? So those questions aren't answered just in our XML document, but our schema will provide those specifications. And most importantly, when we're dealing with things like Microsoft Access, it is required to have both a schema and an XML document when we're trying to import data into Microsoft Access. So if you just have that XML document, it's not going to be enough to get it into Microsoft Access. That's because that schema provides a lot of information to access, like what kind of data types these fields should be. So just like with the XML document, there are rules we have to follow when we're making a schema. The most important is to remember that an XML schema is in itself an XML document. So that means the schema has to follow the same XML syntax rules. For example, whenever we open a tag, it has to be matched with the matching closing tag. We have to follow the same sort of naming rules. We can't start lines with XML, we can't have spaces and names, things like that. So each and every element that's in our XML document has to be defined in our schema. So for every element that's in our XML document, there has to be a matching definition in our XML schema. And the elements in our XML schema have to appear in the same order they do in our XML document. And schemas must use a namespace. So we didn't talk about namespaces in the last tutorial video, but they are in the tutorial slides on OWL. So if you haven't taken a look at those yet, I do recommend you look over the XML tutorial slides and make sure you're familiar with the concept of namespaces. So the other rule is that XML schemas must be associated to the XML document. We'll talk about that a bit at the end, but to say that this XML document is following a specific schema, there's something we're going to have to add to the XML document at the end, just to say this is the schema I'm following. So what we can see on the screen right now is an example of an XML schema, and we're going to sort of go through and talk about what each of this part of this is. So we're going to sort of give the autonomy of this XML schema. And this is an XML schema for an example very similar to what you've seen in the slides on OWL. I show it up here right now. So this is what the XML document would look like in that purple box. So in this case, it's that friends list example. But one difference is that instead of having all the hobbies in their own sort of hobbies element, they're now just listed individually in the person tag. So that's a completely valid way to do it. In this case, we're going to show how we would specify that it has to be done like that instead of in the hobbies list like it is in some of the slide examples. So the very first thing at the top of this schema, which we see on the left here, is the preprocessor command. So that shouldn't be too surprising. I did say that XML schemas are XML documents, and one of the rules for XML documents is that they should always start with this preprocessor command that basically says, I'm an XML document, and this is my version number. So just the same here, we're saying that this is an XML document following XML version 1.0. That's going to be the version you're going to be seeing in most cases, because the only other one, 1.1, isn't really used. So the other big thing that XML schema documents have to do is they have to have a namespace. So you can see up here that we're defining a namespace. We're calling it XSD, and we're saying that it's going to be defined by this ULR. So this ULR is special in the terms of schema documents. It can't be any ULR you want. It has to always be this ULR when you're making a schema document. And as we've seen in the namespace examples, we always have to name all of the elements. We have to sort of prefix them with the name of the namespace. So in this case, we're calling the namespace XSD. So that means that every element in this file has to start with XSD and then a colon. So remember that the name of the namespace doesn't really matter. We could change it. For example, I changed it here to pizza. That's completely fine. The only rule is that it has to use that special ULR, and that ULR states that this is a schema file. So in this case, I could change this namespace's name to absolutely anything. In this example, I've changed it to pizza. So in some examples you'll see it'll be XSD, some examples might show XS. The word here doesn't matter as long as it's following the XML name rules. It can be anything following those rules. And the key thing here is that you have to use that namespace name in front of each element in your schema file. So you can see how pizza right now is being used in front of each one of those element names. The other important thing to note is the namespace in this case has to go in the root element. The root element for a schema document is always an element called schema. And that would be prefixed with your namespace name. So in this case, it's pizza:schema. And just like with other XML documents, it has to have a matching ending tag. So at the end here, you can also see that we are closing the schema tag. By root element, we mean an element that basically stores all other elements. And in XML, that means that we have to have only one root element. Against the rules to have more than one root element. So you can see in our XML example up here, the root element would be friends, and that contains all the other elements. So just the same, we have one root element here called schema, and that's going to contain all our other elements, which define different things in our specification. Now we're going to go through and talk about what each one of these things does. So each one is basically a definition of something in our XML document. So the first one we see here is called XSD:element. Remember, the XSD part's just the namespace name, so the real name here is element, and it defines an element in our XML document. It takes an attribute called name, and that declares what the name of the element in our XML document is. In this case, our root element in the XML document is friends, so we're defining the root element right here with this line, and we're saying that it's going to be equal to friends. Remember, these are case sensitive, so that means that the capitalization has to match. So if we called this friends with the lowercase f, it would have to be friends with the lowercase f in the XML document. So whenever we have an element in our XML document, we should have a matching element in our schema that says element, the name, and that element's name. Also, like I was mentioning before, the same rules apply, so we have to have a closing element. So just like in the XML document, friends here is a complex tag, or a complex element rather, meaning that it contains other elements. The friends element in the schema document that defines it is also going to be complex, and it's going to have all the other elements definitions that it contains in the XML document. So it might seem a bit confusing, but it's a bit natural once you get into these documents, because it will have the sort of the same layout and the same structure as the XML document that you're defining. Next we see here, we see two elements, one called complexType and one called sequence. So whenever we have a complex element, in this case friends is complex because it contains other elements, we want to use these two tags in our schema document to say that this is a complex element. So complexType element over here is saying that this is a complex element, and it applies to what's inside of. So since this is inside of friends, we're saying that friends is a complex type. And the second one down here says that the sequence is going to matter. It means that it's going to have a sequence of other elements inside of it. So it means the order is important. So everything we're going to be doing in this class is going to be using sequences when we use a complex type. But if you want to look into it on the W3 School tutorials, there are a few other options where you can sort of like change how the order matters. But for us, we want the order to be the same, so we're going to use sequence. And again, we have to have a matching end tag. And be careful here, you have to keep these in the opposite order. So we see sequence complex type, when up here it was complex sequence type. The reason for this is we can't have overlapping tags, we can't have overlapping elements in XML. So since we opened sequence last, we have to close it first. Sort of like a last in, first out type system. So inside these tags, we're going to define all the other elements that are going to occur in these tags in the actual example up here, the friends one. So since the friends is the root element, that means all the other tags are going to be defined inside of the friends element. In this case, those would be person, name, age, and hobby. The next element we will define is the person element. Again, this is a complex element because it contains other elements. In this case, it contains name, age, and hobby. So just like we did for the friends element, we're going to use an element tag to define person, followed by a complex type and a sequence tag.
as this is a complex element. You may have also noticed that we have something a little bit extra right here. That would be the maxOccurs attribute. maxOccurs defines how many times this element can occur in its given grouping. Right now we're dealing with the person element, and by saying maxOccurs equals unbounded, it means the person element can occur an unlimited amount of times. So we can have an unlimited number of friends in our list. You'll notice we don't have the maxOccurs attribute in all of our element definitions. For example, the friends element definition does not have any attributes. maxOccurs is an optional attribute. This means that if we don't provide the maxOccurs attribute, it defaults to 1, meaning at most there can be one instance of this element in the given grouping. This is true of both maxOccurs and minOccurs, which we'll get to shortly. If they're not specified, they both default to 1, meaning that the element must occur exactly one time in the given grouping if you don't specify any maxOccurs or minOccurs. As we did not specify a minOccurs value here for person, it defaults to 1. It means that we must provide at least one person in our friends list. If we wanted to change it so that there could be no one in our friends list at all, we would have to add a minOccurs attribute and say that it equals 0.
So now we're getting to an actual simple element. By simple element, I mean elements that only contain data. They don't contain other tags, they don't contain other elements. In this case, name is simple because it only contains the friend's name, in this case, Billy. So to define a simple tag, it's a little bit easier. We still use that element, and we still use name to define its name. In this case, we're saying the name is name. But now we have to add a type. So what the type is we're saying what the type of the data is. In this case, we're storing a name, Billy, so that's text, and we call that a string. We'll take a look at all the types in a few seconds. One thing I will mention is in this example, we are calling this tag name. Recall in the last tutorial, I suggested not using name as the name of a tag because it conflicts with the built-in access type name. So this is only important if we're going to be importing this data into Microsoft Access. If you're not, it's completely valid XML to have a tag name name or using any other Microsoft Access word. So like I mentioned here, this is the type of the data that will be stored. And this is both a way to tell people that are reading your schema what kind of data they should provide here, as a way of enforcing it. So when we get to validation later, these data types will actually be checked, and the validator will check that the only text inside that name element is actual text, like characters and letters. So I've provided a list of the most commonly used types here. So string, like we mentioned, is basically any text, any combination of words, letters, numbers, and punctuation. The only restriction is there's those few special characters that we talked about for XML. Those have to be escaped. So like if you use an and sign, an ampersand, you're going to have to escape that. Another commonly used data type is decimal. That would be any real numbers. Those are numbers with decimal places. There's integer, and that's any whole numbers. Those are numbers without decimal places. There's Boolean, so that's only going to store true or false values. There's date, which stores dates, but it has to be in a very specific format that I list here, and that's the year-month-day format. There's time, which stores times in a 24-hour format, with the hour, colon the minute, colon the second. And there is ULRs, or URIs rather. It's a slight difference between URIs and URLs, but for our purposes it just means we could store ULR. So there are many more data types, and you can read about those in the W3 school tutorials, but for the vast majority of what we're going to be encountering, both in real life and definitely in this course, it's going to fall into one of these. One thing I'll note is you see the XSD in front of these types, which just changed to pizza, is that this is always your namespace name. So if you changed your namespace name to something else, like pizza, you'd have to also change the name of these types. The string or the decimal part always stays the same, but the namespace prefix will change. If we called this pizza, changes to pizza colon string. If we changed it to XS, it would be XS colon string. If we're leaving it with XSD, it would be XSD colon string. Always the name of your namespace. The other thing I should mention is that we said that every element needs a closing element. So when we open an element, we need a closing element. But these ones don't seem to have them. And the reason for that is the special slash symbol at the end, the / at the end of the element. So this is sort of a shorthand in XML that says that this element doesn't contain any information. There's no data stored in this element. So instead of writing it out and just having no data there and then having a closing one right after it, this is sort of a shorthand for the same thing. So it would be perfectly valid if you wanted to open this element up and close it right away. That'd be fine. But since we don't want to do that and we don't want to accidentally put like some blank white space or space characters in there, we'll just use this notation. It also saves a lot of space when we're typing out our document. So remember, when we have a / at the end of an element, it means that it's opened and closed in that one statement. It means this element contains no data. So now we have an age element. This is another simple element, so we're going to just define it with one line in our XML schema. We're saying that its name is an age, and this type we're using a different type. We're saying the type is integer. And since we don't have minOccurs or maxOccurs, once again we're saying that this has to occur once and only once. Now the hobby one's a little bit more interesting because it can occur more times. We see in the example on the right here that it occurred twice, saying that this person has 2 hobbies. So we still define it similarly. It's still considered a simple element because it's only storing data, even if it can occur multiple times. We use the name argument to call it hobby. We use type to say that's a string because it's storing text. And we add minOccurs and maxOccurs because this can occur a different number of times than the default. So by saying minOccurs 0, it means that a person could have no hobbies. So that would look like an XML document with these lines completely omitted. It would just have name and age. And according to our specification, that would be valid because we're saying it could occur 0 times. By saying maxOccurs is unbounded, it says that a person could have any number of hobbies. So we could have a person that has like hundreds or thousands, any number of hobbies, or we could have someone with no hobbies at all. They would have none of these tags in their record. So minOccurs, how many times it has to occur. If it's optional, if they don't have to have a hobby, for example, we set it to 0. If it has to occur at least once, we can set this to 1, or we can just omit it because that's the default. maxOccurs, if it can occur only one time at most, once and exactly once, we'd set this to 1, but we don't have to write it out because that's the default. If it can occur 10 times, we'd set this to 10 inside those 2 quotes. If it can occur any number of times, an infinite number of times, we set it to the word unbounded. So very important, we were going top to bottom in this XML document. So we went from name to age to hobby, defining them in the same order, because one of the rules was they have to be defined in the same order. But now we just got to a second hobby one. So do we add another hobby definition? And the answer to that is no, because we only want to define each element once. So we don't mean that we want to define each instance of an element. That's not what we mean. We want to define each element once. So for each unique name, there should be a definition in our schema. There shouldn't be a definition for each time it occurs, just for each unique name. So at this point, we've already defined hobby. We've said that it could occur multiple times, so we don't need to add any more definitions for this. So this is fine. And at this point in the XML document on the right, we've basically gotten to the end. All of the tags have been defined. There's no unique tag name that isn't defined in our schema, so that means the schema is complete. It is a complete specification for this XML document. So now we're going to get right back into that doctor's office example from the last video. So if you recall, that doctor's office example is the one we've been building on for a few weeks. This is a case where we have a database where nurses are assigned to doctors, as in they work for that doctor, and doctors can order tests. In the last video, we worked on the case where we're going to be importing some patient lists into our database, and we first created a XML document to store those patients and their medication list. So in this video, the next step is going to be to create an XML schema that defines the structure of that XML document that we made in the last video. So this is the XML document from the last video. Take a little bit of a look over it. It is quite long, so this might seem like it's going to be a daunting task, but remember we only have to define each unique element. So we don't have to go through this whole document, we only have to go through what are the unique elements. You can find a copy of this XML document that I have right over here in the slides on OWL, and it's going to be called patientlist.allrec.xml. So I highly recommend that you download a copy of that and you follow along with this tutorial, pausing at each step and trying to sort of figure out how to make the schema yourself, and then unpausing once you think you have an answer, and then sort of checking it with what I do. Following along like that is a great way to sort of get practice with the actual practical side of the things we're covering, rather than just watching the video. So go download that right now. Names listed up there. Once you've done that, unpause, and we'll continue along making the schema for this document. So we'll just be putting this over to the side. And similarly to how we went through the raw data top to bottom to make the XML document, we're going to go through the XML document top to bottom, at least until we run out of unique elements, to make our XML schema. And like I said before, don't worry, we're not going to have to go through that whole document just until the data starts repeating, because at that point it means we've gone through all of the unique elements. So it might seem complex and it might seem a bit daunting, but once you start actually getting into it, you'll see that it's pretty straightforward. So the first step, remember this is an XML document, so we always start by adding that preprocessor tag that just says this is an XML document. So even when we're making a schema, since it is in itself an XML document, we need to add this preprocessor tag. And that tag's always the same, and it always has to be the first line in your file, with no spaces and no lines on top of it. So the next line we have to add is the root element for our schema. Recall from that quick review, the root element for an XML schema always has to be called schema, and it always has to contain the XML schema namespace. So in this case, I'm calling the namespace XS. So the ULR always has to be the same, but the name of the namespace doesn't. Remember, we saw an example with pizza, we saw an example with XSD. In this example, we're just going to be using XS. The name you see in red here doesn't matter, as long as you're consistent and use it throughout your schema document. Now the other big thing is that we add in the closing tags as we go. So when we're making the XML document, we had those groupings already made so we could see where the end tags would be. In this case, we're just sort of like hunting for unique elements as we go from top to bottom. So it will be really helpful if you add in the closing elements as you open them. This way you don't have to go at the end and try to figure out where each one matches. So make sure you always, when you add a new element to your schema, you add a corresponding closing element. I also highly recommend indenting as you go, just to make it really clear what element's inside of another element. Otherwise it will get really confusing if everything's just completely left aligned. So we're starting top to bottom in the XML file over here. So in the background we see the XML file, and the green box here is going to be our schema file. So these are two different files. We start at the top and go to the bottom, and each time we get to a unique element, we're going to add a definition for it in our schema file. So you'll notice that we skipped these 3 lines here, and that's because this is just a preprocessor definition. It's not an element. It shouldn't be defined in your schema. These 2 next lines are comments. So those are also a type of preprocessor definition that just adds the notes for humans. So these aren't elements that we have to define. They're just comments that are going to be ignored by the computer anyway. So the first element that we are going to get to, and it should always be this first element, is the root element of your document. So it might not be named patient list, but it will always be the root element. It will be the first element that we get to, and the root element will be the first one that we should be defining in our schema. So in this case, the element is called patient list. So we're going to add a new element tag in our schema with the name equals patient list. That defines that there's going to be an element, and it has to be named patient list. Because we opened up a new element, we're going to add a matching closing element. Like I said, we always want to close it as we open them. And we're just going to put a lot of space in between because we don't know how long this is going to be yet, but we do know the other things are going to go in here. How do we know that? Because patient list is a complex tag. It's also the root element, so by definition that means it has to be complex, assuming it has something other than just data, and it has to contain absolutely everything else. So that means, since it's a complex tag, we're going to need to add in that complexType element that we see right here, and we're going to have to add in the sequence element that we'll be using, just to say that it's ordered data. So the order of these elements matters, and in our XML document, they have to come in this order. Once again, we want to add in the closing tags as we go, and I will point out again that these are in the opposite order. That's because we want to close the last one that we opened. So sequence was opened last, so it has to be closed first. Otherwise, they'd be out of order, and they would be overlapping. And we're not allowed to have overlapping tags. That's one of those XML rules that we talked about. So that's it for patient list. We now have an XML schema that defines one single element, patient list, and it says it's complex. So we're going to do the similar thing. We're going to go top to bottom for our XML document. Each time we get to a new element, a unique one, we're going to define it in our schema. If it's complex, we're going to use the complex type and sequence. If it's simple, we're just going to use one line, like we saw before in the quick review. It's important that we go in the same order, top to bottom, because they have to appear in the same order in the schema as they appear in the XML document. The next one we hit is patient. So we add the corresponding element with the name patient. Once again, those are case sensitive. So in this case, it starts with a capital P. So we have to make sure it's capital P in the schema. And since we opened an element, we have to close it. So we're just sort of stacking all the closing ones on the bottom in the same order, and I'm just indenting them. So each time we go in a level in the XML, we want to tab it in an extra little bit of space in front of it. So before we go adding the complex type element and the sequence element, we should think about how many times does this element occur. So whenever we add an element, we should ask ourselves this question. How many times does it occur? What's the minimum amount? And what's the maximum amount? How many times can a patient occur in this document? Well, in the example that we have, we had 3 patients. So we know that it can occur 3 times. But how few patients can there be, and how many maximum? Well, if we think about it, this document would be pretty useless if it didn't have any patients. I mean, we wouldn't really be having much of a patient list with no patients on it. So we could probably guess the minimum is going to be 1. What about the maximum? Well, there isn't really a maximum, so we would say 1 to many, or that it's unbounded.
In this case, we'll have to add a special attribute to define the number of occurrences of this element. If you remember from earlier, these would be the minOccurs and maxOccurs attributes. Here we set minOccurs to 1 to say that at least one patient must occur in the patient list. We can't have an empty patient list, and by setting maxOccurs to unbounded, we are saying that there can be as many patients as we want. That is, the number of times a patient element can occur in the patient list is unbounded. Now, you may also recall that the default for minOccurs and maxOccurs is 1. So in this case, we don't have to manually specify that minOccurs is 1. It could simply omit this attribute, as it will default to 1 anyway.
So remember, this patient is a complex type, so we have to add in the complex type tag and the sequence tag. So in everything we'll be doing in this course, whenever it's complex, we always have to have these tags following it directly. So I'll move this down here, just so we have a little bit more room. So the next thing we're going to get to, because now we're inside that patient element, is the card number. So in this case, card number is a simple element. It means that it doesn't contain any other elements. It only contains data. And in this case, that data is the health card number. We even have a little comment on the end there that says Ontario health card number. We just completely ignore this because it's a comment, it's ignored by the computer, and it can be ignored by us when we're making our schema. So we've wrote in so far element, and we've said the name is card number, but we still need a little bit more here. Remember, when it's a simple element, we have to define a data type. So we have to say what kind of data can be stored in this element. So you might be thinking, well, it's card number, maybe this should be a number, maybe it should be an integer, maybe it should be a decimal. But when we actually look at the formatting of the data, we have a few extra things in here. We have dashes, and we have 2 letters on the end, A, B. So there's only one data type that we've seen so far that would allow this, and that's going to be string. So remember in that table it said XSD :string, but in this case, because we're calling the namespace XS, it has to match the namespace name. So it's XS :string. If this was pizza, it would be pizza :string. And once again, string means any kind of text, any kind of combination of characters and letters. So we keep going down through the file, and the next record we're going to get to, or the next element rather, is patient name. In this case, Joe Blogs. So again, this is a simple type. It only stores the patient name. So all we have to do in our schema is add an element, give it a name, patient name, and we're going to say that it's a string. Because patient name has letters, it has to be a string. It can't be a number. There's no numbers in that. It has to be a name. Again, you'll notice that we have the forward slashes on the end of these, and that means that this both opens the element and closes the element. As it's a simple type, we don't have to have anything inside of it. So that's all we need when we define a simple type. Also note that we don't have minOccurs or maxOccurs, so that means it's going to be the default. So for both of these, cardNum and patientNum, we're saying that it has to occur once and only once within a patient record or within the patient element. So we can obviously have other patients with other card numbers, but each individual patient can only have one card number, and each individual patient can only have one name, which makes sense if you think about it. So we keep going down the file, and the next thing we're going to run into is the phone number. So once again, the phone number could be formatted as a number, but if we actually look at the data, we have special symbols here. So we have brackets, we have dashes, things like that. So it's going to have to be a string. If we wanted this to be formatted as a number, we'd have to actually change the XML document and make sure we removed all these characters. But in this case, there is something else we have to consider. And that is, if you remember the original XML document, not all of the patients actually had phone numbers. There are some patients, I think it was Jane Doe, who didn't have a phone number listed. So we're going to have to add a little something else to this record. In this case, it's going to be a minOccurs. So by saying minOccurs 0, we're saying it doesn't have to occur at all. So the minimum is this element could not be in the record. So that means that this is optional. So if we have some kind of data field, some kind of element that is optional, we have to make sure we have a minOccurs equals 0. So again, the maxOccurs isn't listed, so it's going to be the default of 1. So this means that this element can occur 0 to 1 time for each patient. So each patient could have no phone number, or they could have one phone number. If we wanted to do a little bit more complex example, maybe patients could have multiple numbers, like a cell phone number, work number, so maybe we would want to increase that a bit. Or we could change the format so that we'd have one element named home number, one element named cell number, and so on. But for the case we're dealing with, we're saying that phone number is optional and it can only occur a maximum of once. So the next line we get to, going top to bottom, is address. So in this case, address can contain all kinds of characters, commas, periods, letters, numbers, so it's going to have to be a string. And it's a simple type because it only contains data, and it has to occur once and only once. So we can leave out the minOccurs and the maxOccurs, and it will go to the default. So if you really wanted for things like this, you could put in minOccurs equals 1 and maxOccurs equals 1. There wouldn't be wrong at all. It would just be more work on your part, and your file would be a bit more bloated. So that's completely correct. It's just not needed. So what I like to do is whenever there's a default, use the default when it's inappropriate, so you don't have to do more typing. That makes the files a little bit easier to handle. You don't have to search for, when there's an error, you don't have to search for more things where it could go wrong. So moving the file down a little bit so we can see the rest of the XML behind it. The next thing we're going to run into is doctor ID. So if you recall, doctor ID was that ID is going to be a foreign key eventually from our database. So it is that primary key from the doctors table. And that is always a whole number in our Access database. Remember back from the Access tutorial. So in this case, since it's a whole number, the data type we have to use is integer. So integer means that this element, doctor ID, can only contain integers. So if the doctor ID was something different, like maybe it was a foreign key that could start with like a letter, maybe like D001, in that case we'd have to use a string. If it was some weird case where it could be a decimal number like 1.13, then we'd want to use the decimal data type. In this case, it's always a whole number, so we're going to use integer. When you're going to be importing this into Access, you have to be really careful here because you want to make sure it's going to match the primary keys data type in your actual database. So we'll zoom out a little bit and push the data up so we have a little bit more room to work with. Remember, the green is our schema and the text at the top is the original XML document. So we've got through all those simple elements at the top of the patient record, and now we're moving into the medication list. So the first thing we hit is this medication list tag, which sort of defines that we're at a list of medications.
It has one attribute, named last update, which was the date the medication list was last updated. As the medication list will hold other elements, this means it is a complex type. However, it's a bit different than the other cases we've seen so far due to this last update attribute. For now, we'll make a note about this special case and deal with the last update attribute after we have defined the medications element and everything inside it. Let's start by defining the medications element and make sure to also include the closing tag. Medications is a complex type, so we need the complex type and sequence element. Don't forget to also add those closing tags.
So the real question is, how many times can the medication list occur? So this is a good question, so I recommend pausing the video, try to think about it. How many times can a medication list occur for each patient? It's a bit of a tricky one. Once you think you have the answer, unpause. Okay, hopefully you thought about it. In this case, what do you think it's going to be? Exactly once? Can the medication list occur exactly once? Or 0 to 1? So you might have said that it can occur any number of times. But the key thing here is that we are considering the list of medications as a whole. So each patient has one list of medications that can contain many other medications. It'd be weird if they had two different lists. Each patient should have at most one list. But there's a choice. Do they have exactly one list of medications, or they have 0 to 1 list of medications? So this is actually a bit ambiguous. There's not one correct answer in this case. But how the document would be structured would be a little bit different depending on which we pick. If we pick 0 to 1, that means the patient could just have no list of medications in the record. If we say exactly 1, it means they're going to have the sort of medications tag, and maybe that will be empty. That's not what we're defining here. It's important to note that right here we're not defining how many medications are going to be in the medication list. We're saying how many medication lists itself. So I realize that could be a bit confusing. So you should think about it as sort of like how many pieces of paper have we written a list on. So if we write our list on a piece of paper, saying that we have multiple medication lists would mean we have 2 different pieces of paper or more that have lists of medications on them. Saying that we have 0 or 1 medication list would mean that the patient either has that piece of paper that has the list of medications on it or they don't. So in this case, we're going to try going with 0 or 1. So because it makes sense that patients might not be on any medications. So in this case, we're going to say they either have that list with medications on it or they have no list. That doesn't mean that there has to be only one medication. The list still can have many medications on it. There's only one list itself, or none. They either have that list or they have no list. And we define that with the minOccurs and maxOccurs. Once again, maxOccurs is using the default value of 1, so we can eliminate it here. So now that we have the medications list defined, we have to actually define the definition for each medication record itself right there. But we're running out of a little space on the left, so we're going to move things around. I moved that up, and now the XML is up here on the right. And I've sort of abbreviated it a bit. So what we're seeing here is the medication list for Joe Bloggs, and we're only seeing one of the medications so far. I'm going to work with that for now. The dot dot dots represent where there's actually more stuff in the XML file. So we're still going top to bottom, and the next thing we're going to hit is this medication tag. And this denotes one specific medication. So it's a complex tag. That means that inside of it, it contains individual fields or individual data elements about this specific medication. So you can see here that I added that element and named it medication to match. But now the question comes up again, how many times is this going to occur? So it's important to remember that we decided before that the whole list can occur 0 times, so they could have no list or they could have one copy of the list. But how many times can each medication itself on that list occur? So that'd be like how many items are on the list, regardless of you have one or not. So you might want to pause the video and try to think about it. Is it unlimited? But what would the minimum be? Okay, hopefully you gave it a little bit of thought. So as it says down here, it's probably unlimited unbounded in terms of the maximum. That's pretty easy to guess if you've got a patient with a ton of medications. So we're probably going to want to go with unbounded for the maximum. But what about the minimum? So once again, this is sort of ambiguous. It could be 0, it could be 1, but it is going to change how your document is structured. So let's say we went with 0. Well, like I said, we have to have unbounded for maxOccurs because you have any number of patients. But what happens if we went for 0 for the minimum? That would mean that we could sort of have these sort of structures in our document, where a medication list would have medications, and it could just be completely empty. So the question what we're really asking here, whether this should be 0 or 1, is if you have that list, can it be empty? Could you have the list and have nothing on it? Or could you have the list and it has to have at least one record on it? And this is an important distinction because it has to go in hand with the number of lists we can have. So we said before we either have the list or we don't have a list. But if we have the list, how many items does it have to have on it as a minimum? Does it make sense for someone to have a list with nothing on it? That's what it would look like in the XML document if you had the list of medications with nothing on it. It would just be a start medications tag followed by a close medications tag with nothing listed. So since we already enforced or are enforcing the rule that you either have a list or you have no list at all, then it might make sense to say that we have to have 1 here. The reason why is because we're already saying you cannot have a list. So we're not saying that patients, if we use a minimum of 1, have to be on a medication, because we can say they could not have the list at all up here. What we're saying that if you have a list of medications, you have to have at least 1 medication on it. You can have no list of medications, but if you do, it has to have at least 1 item on that list. So this is a bit confusing, but you might want to try it out with different minOccurs and maxOccurs, and then playing around with different medication lists, like some that have nothing in them, some that have the whole medication list missing, because there is some quite fine details here. And for the most part, what choices you make here aren't going to be super critical in terms of what data can be stored. They're all going to probably allow you to store the correct data. It's going to be what's going to be valid in your document format. Do you want to have lists with no items? Do you want to have patients always have to have a list? Maybe they can always have to have that list, but it's allowed to have no items on it. So it really is defining some sort of the ambiguities in your document. Because before we had the schema, it's not really clear how we would say that a patient doesn't have any medications. So by setting these, we're saying, at least in this case, that you either have the list or not, and if you have the list, it has to have 1 medication on it. So it's sort of cleared away any ambiguities. So now that we've resolved this minOccurs, maxOccurs issue, at least hopefully, we need to note that this is a complex element. So medications is a complex element because it contains other elements. So we do have to add in those complexType and the sequence tags. And once again, we need to match the closing ones. Notice the document's getting big, so it's just pushing it down. I'm not deleting lines, they're just off the screen. Push it up a little bit. So now we're actually inside of medications. We're going to start adding these simple elements that are in it that define the different parts of each medication. The first one is the medication name. That's going to be a string because it just stores text. Simple element, so we just need one line that closes itself. The next one is dosage, and since this can have decimal points, like the 0.6 here, it means we're going to have to use the decimal type. Decimal type means that it can hold real numbers, so that's numbers with decimal places. Sort of self-descriptive there. The next one is going to be the instructions, and that's basically instructions from the doctor. So in this case, it's going to be a string because it could be whatever text the doctor wanted to type in there. Next, we have days, which is the number of days or the course of the medication, how long they're going to be taking it. And in this case, it's going to be an integer because in our XML document, we noted that it's always a whole number of days. So by integer, we mean no decimal places. So the last element in here was the patient card number again. Remember, we needed to add this because we're going to be importing it into Microsoft Access, which means that we need a foreign key because Access wasn't quite smart enough to put it in for us. So this is always just the foreign key that matches the card num above. And we're going to say that it's a string because card num was a string. So we have to use the same type as the foreign key because we don't want to have different types that will cause issues when we start importing it into the Microsoft Access database. So now we've been going through and we just got from the end of one medication and we're starting the next medication. So what do we do now in our schema? Do we move on to this next medication record and start defining another medication element in our schema and then start adding another medication name and so on? Or do we do something else? So think about your answer and pause the video. Once you think you know what we're going to do next, unpause it and let's see if you're correct. Okay, so if you remember from the example from before in the quick review, I did say that we only want to add each unique tag. So at this point, we've already added a medication element. We've already defined it. So if we started defining another medication element, we wouldn't be defining a unique tag because we're redefining it. So the same thing with medication name, dosage, instructions. The data is starting to repeat here. So we don't need to add another definition. We only want to define each one the first time we see it. So no, we're not going to keep defining them. Instead, we're going to just keep going on at this point for the file until we either get to the end of the medications list or we find another unique tag. So if we kept on going, we'd eventually hit the end of the medications and we should start adding in that special case.
Recall that the medication list had an attribute. In this case, it had an attribute named lastUpdate that stores the date the medication list was last updated. Just like with the elements, we also need to define attributes in our schema. This definition is placed right between the closing sequence and complexType tags for our medication list. And it is important that it is placed exactly here, inside the complex tag, but outside the sequence tag, for it to work correctly.
So to give you a better idea, I've sort of highlighted the different levels in this document. So in yellow here, we have the medications definition, and everything inside this yellow box is inside the definition of the medications element. So that means everything in here is going to be elements that occur in the medications list. So you'll see that we have complex type, that's defining that this is a complex type, and that's the part that actually holds everything else. And then we have sequence, which holds all the elements. And then inside there we have the list of medication and then all the simple tags.
Okay, So let's now add the definition for the last update attribute. As it's part of that medications element, that's our medications list, it will be placed between the closing complexType tag and the closing sequence tag. It is important to keep in mind which closing complexType tag and sequence tag are for the medication list element and which are for the other complex elements. A good way to do this is to indent your schema document properly so it's very easy to see how everything lines up and what's part of what complex element. The way we define the attribute is with the attribute element. This works similarly to the element definitions we've done so far, but starts with the text attribute, including the namespace prefix. The name and type attributes work the same. In this case, the attribute we're defining is named last update, so we set the name equal to last update. This attribute will store a date, that is the value found between the quotes in the XML document, so we have to set the type here to date. Unlike element definitions, we don't use maxOccurs or minOccurs for attributes. If an attribute must always be present when a given element is part of the XML document, we would say that that attribute is required. If the attribute may or may not be present when a given element is found in the XML document, we would say that attribute is optional. In this example, every time we see a medications element, we see that it also has a last update attribute. This means, at least in the examples we've seen, the last update attribute is required. This is controlled by the use attribute. Setting use to required means that whenever we have a medications list, it must have a last update attribute with a given date. If we set this optional, then we could have one or more medications element without a last update attribute. By default, if we do not specify a use, the attribute would be optional. So if we want our attribute to be optional, we could simply omit use here. However, in this case we want it to be required, so we must give the value as required.
So we're not quite done yet. If we kept scanning through the file, we would eventually find another element that we haven't dealt with yet. And that is the birthdate element. And remember that was sort of stuck in at the end of the patient record, right after the medication list, but before the end of the record, the end of the patient tag. So birthdate is a required one. It has to always occur. Patients always have to have a birth date. And it is a simple element. But the question is, where is it going to go? So I've just sort of like highlighted the different areas here. And remember that this should be inside of the element that it is inside of in the XML document. So in purple, we have the medications element where we defined it in the schema. So this would contain all the things in like this medication list here. We don't want to put birth date in here because that would say it's part of medication. So where would it go in here? So this is another one where you should try to think of what the answer is. Where would we put this? Pause the video. Once you think you know where it's going to go in the schema, unpause and let's see if you're correct. So hopefully you've had a few minutes to think about it. And we are going to be putting it in this blue box. Reason why is this is going to be part of the patient record, but all of the elements that we define for the patient record, all things that are inside that complex element, have to be inside this sequence. If we were to put it outside of sequence, like outside the complex thing, our schema wouldn't be valid because it wouldn't be inside the complex type and it wouldn't be inside the sequence type. So we have to put it down here after the closing element for medications because it comes after medications in the patient record or in the patient element. And this is pretty straightforward. It's the element type for a simple element. So it's just going to be name, birthday, and the type is going to be date because it is in that date format. We could use string for this. It would be valid, but we might have some problems when we import it into Microsoft Access or when the computer tries to interpret it. So usually we can get away with using string for anything, but the problem's going to be when the computer is processing the file. Because then it's going to be processing it and thinking it's text, so you're not going to be able to do anything special with it. So if we did something like birth date, if we did it as text, we wouldn't be able to then later on when we get to queries, make queries that say like anyone who's older than a certain age or anyone who was born after this date, because the computer would think this is just text. It doesn't know that it's a date. So it is important to use the correct data type, even if you could get away with using string. So only use string when that's like sort of like the last resort, if no other data type applies. In this case, date applies. It's in the correct format for date, so we'll use date. So finally, we have a complete XSD document. We don't know if it's valid yet. We don't know if it works, but at least it's complete. So how do we know that it's complete? It's because if we looked at that XML document that we're going through to make this, there's no more unique elements left. So every single element name in the file has a matching definition in our schema. So remember, that's for each unique element. So there are probably more medications, more patients listed in the file, but they don't have any extra elements that we haven't addressed yet. So each element should be defined in our schema once and only once. And since that's the case, we know that we're done. And since we've been adding in the closing tags as we go, we know that each one of these should be closed. So if you didn't add them in as you go, you're going to have a problem now, because now you have to go through and make sure you match up each one and they're all closed, which is very easy to make mistakes with, and it's going to be a big pain. So hopefully you're always adding those closing types as you go, so then when you're at this point, you're just done. You don't have to stress about it. So the last step, at least before we do validation, just like with the XML document, is to add any comments or documentation. So this would just be for the human reader. The computer's going to ignore them, but we might want to make some stuff clear, like we could clear up why we did certain things. We could add what the schema is for, and basically comments, so if we ever come back to this later, or if we're handing this to someone else, they can better understand it, just for the human reader. So we use the exact same syntax. It's that exclamation mark followed by 2 dashes. You can see I've added 2 here, one at the top that just says this is a schema for my patient list file, and that it validates a list of patients. And you can see I added a little comment down here that says it's not an integer. Remember, even though it says card number, we're using a string because it has dashes and letters in it. You also notice this is a bit different than the comment we saw in the last video. It's called a multi-line comment. So we're allowed to open up the comment like this and then just type in as many lines as we want, as long as it's followed by a closing part right here. So there's 2 ways we could do multi-lines. We could do on each line, add in the bracket, exclamation sign, dash, dash, and then close it on the same line and just have multiple of them going down, like we saw in the first XML example. Or we could open it once and close it once, and anything between the opening and closing there would be considered part of the comment. So any text in here is part of the comment. And we can do same line comments just like this. That's completely valid, just like we saw before. So for your assignment, I do recommend that you document your XML code and your XML schema, just so everything's completely clear for the TA. And there'll also be a requirement that you have to add a little bit of extra information that's only for humans, like your student ID, so maybe this might be a good way to go about that. The next step is validation. This is actually several smaller steps. So the first thing we need to do is we need to check if the syntax that we just wrote in our XML schema is actually valid XML. Recall that XML schemas are in themselves an XML document. So the first thing we need to do is check that the XML that we wrote is valid XML. After we've done that, then we can worry about checking if it's a valid schema, and then if our XML document complies with this schema. So first, we just want to know, is this document that we wrote, this XML schema, valid XML? For this course, there's 2 ways we can do that. We can use the Notepad++ XML Tools add-on. This is what we recommend you use, because it allows you to check as you're writing the document. Or you can use xmlvalidation.com. This is a site where you have to upload your schema or your XML document and keep uploading it to check if it's valid. So if you're able to, we recommend using Notepad++ to validate. Otherwise, use xmlvalidation.com. So we're going to switch over to the desktop and try out doing this XML syntax validation on our schema. So first we're going to open up Notepad++ because we're going to be trying out doing the validation with Notepad++. If you're going to be doing the validation using the website that I mentioned, xmlvalidation.com, you can skip to this point in the video right here, as you won't be needing to see how you validate with Notepad++. Otherwise, if you're using Notepad++, which we hope you are, watch this. So open up Notepad++, and this is where you do all your work. You'd actually type in the document. So to save us a bit of time, I'm just going to snap my fingers, and the XML schema that we were working on in the slides has appeared in Notepad++. So the first thing we should do is make sure that we save this as a .xsd file. Even though it is an XML document, because it's a schema, we should name it .xsd as the file extension. With the actual name before that can be anything you want. However, for our assignment, we will have a specific naming scheme. So make sure you follow the naming scheme for the assignment, but schemas always end in .xsd, and XML always ends in .xml. So we have our schema here in Notepad++. You can see the syntax highlighting like we've mentioned before. It's not actually part of the file because it's a flat file or a text file. It only contains text. Rather, it's Notepad++ adding these colors, bold, stuff like that, just to make it a little bit easier to read the document. And the way we would validate this is very straightforward. It's just like we saw with XML, because we're just checking the XML syntax at this point. So all we do is we go up to Plugins, XML Tools, check syntax now. So it says no errors are detected, and that's great. That means the XML that we've typed is valid XML. But it's important to note that at this point, we don't necessarily know that this is a valid schema. All we know is that the XML syntax is valid. We don't know if it matches our XML document or not yet. We don't know if it's logically correct. We just know that it hasn't violated any of the XML syntax rules. So when we go back to the slides, we will be taking a look at how we can do that. If you're not using the xml.com validation site, you can skip to this point right here, and we'll take a look at that. Otherwise, stay with us and we will look at the xmlvalidation.com website. Now to validate it, we're going to switch over to our browser. I have this saved on my desktop right now as patient list schema. So the name can really be anything you want as long as it ends in .xsd, but it should be descriptive or follow naming rules. If you're doing an assignment, there'll be stricter naming rules. We have XML validation loaded up. This is going to work just like we did with the XML document, because the schema is an XML document. So we're going to go to the find it. It's on my desktop, patient list schema. I'm going to click validate, and we get no errors were found. So this doesn't mean that it's logically correct. It doesn't mean we correctly followed the XML document. It also doesn't mean that it's necessarily a valid schema document. It just means that it's a valid XML file. We don't have any XML syntax errors. But that's okay, because that's all we wanted to check at this point. Now we're going to head back to the slides and see what we're up to next. Okay, we're back to the slides. And on the screen right now, we have our XSD file, our XML schema, and it's called patientlistschema.xsd. And we don't know if it's working, but we do know that it's valid XML, so that's a good step. Next step is we need to edit our original XML document just slightly to let people know, or let the computer know, that this is now following a schema. So XML documents can declare that they're following a schema, and that's a good thing to include because then people will know that this should be following this particular schema, and it also helps describe the data in it. So just looking at it, it'd be hard to tell if something's like a date or a string. This would make it very clear because it makes it very unambiguous what exactly each data element is. So here we have the XML document from our last video tutorial. Should be exactly the same. I just added a little bit of syntax highlighting to make it more readable. So we're going to have to add one thing just to say that this XML document is following the schema we made, and we do that in the root element of our XML document. So in this case, the root element is patient list. So there's two things we have to add. So we have to add first the new namespace. So this is XML NS, and then we could call this whatever we want. It just has to match over here. And this isn't a namespace where we have to change everything in our file. It's just going to apply to this next line here. you have to use this ULR. And what this ULR says is that we're using an instance of a XML schema. And it allows us to use this directive that follows. So this no namespace schema location means that the schema is going to be located in the same directory as this XML file. And it also says what the name of the schema is. Whatever we named our schema file, and it could be almost anything that ends in .xsd, we have to put that right in here. This has to be the same file name as our schema. This is just telling the computer that this XML document has to follow this schema. And that's going to be important for a few reasons. It's going to be important because it'll allow us to validate this document against that schema, see if it follows the schema, and because it also helps describe the XML document. It says what data type each of these data elements are, for instance. So ULR is always the same, this w3.org ULR. So whenever it's a schema instance, it's going to be this ULR, and this ULR is different than the ULR we're using for the schema, so keep that in mind. This one is -instance, while this one is just XML schema. So this one means I'm a schema, this one means I'm following a schema. And the name of your schema file. So this is really important because it's a common error that I see a lot of students making. It's that these two things, the namespace and the no namespace schema location argument, have to be added to the root element of your document. So these are added to this patient list root element in this case. This isn't a tag that you should just paste on the top of your document. So this name would be different for whatever your root element's name is, and this isn't something that you're just going to paste on top. So a lot of times you see people do something that looks like this, where they add in a new element at the top with this information when they already have a root element. This is very wrong. Don't do this. So this is wrong for two reasons. One, it's not how you properly say that you're following a schema, but it also violates one of the XML rules. And that rule is that you can only have one root element. So in this case, there'd be two patient lists, which means you'd have two root elements. The other issue is that you probably didn't end in a closing tag for this. So there's no closing patient list. So if you tried to validate this, you'd get at least one error. One about being too many root elements, and one about you not having a matching close tag for patient list. So you'd probably be really confused because all you did was just add a schema, and now you're getting all kinds of weird XML errors. So don't do that. Always make sure that you're adding it to your root element like this. We finally finished our XML document as well as our XML schema, and we've updated our XML document to include a reference to that schema. Basically tell the validator or any program processing this XML document where the schema is for this document. But now we need to validate to make sure that our XML document complies with that schema. So what it's doing is we're going to check to make sure that all of the tags, all of the data we have in our XML document follow the rules or the blueprint we've set up in our XML schema. So once again, there's two ways we can do that. We could use Notepad++ XML tools, or we can use the xmlvalidation.com. So we're going to switch over to our desktop right now and take a look at how we can do that. So behind me, we have our XML schema document, just like the last time we validated it. It's still syntactically correct, but we're not 100% sure if it's a valid schema. We also now have an extra tab, and this contains patientlist.xml. So this is our patient list XML file, and it now includes in the root element a reference to the schema. So you can see right here that we have the schema name, and on this computer I have both of these in the same directory. So it is important that they are both in the same directory, and that this name, patientlistschema.xsd, is the same as the name of our schema. And we can see that is the case up here. So to validate if this document is valid against our schema, it's very easy to do. All we do is go to Plugins, go XML Tools, except for this time we don't click Check XML Syntax Now. That only checks the XML syntax of our XML document, which we've already done in the previous tutorial. Instead, this time we want to check Validate Now. So what Validate Now is it's going to look for that reference to the other schema that we added to the root element, And it's going to check if our XML document complies with that schema, if it follows all the rules of our schema. We're going to hit validate now, and we get no errors detected, which is good. However, if we were to do something to sort of change it so there might be an error, like maybe instead of Dr. ID, if we look at our schema, we can see Dr. ID is defined as an integer. Maybe in our XML document we change it to something like cat. That's not an integer, so that should cause some issues. So if we were to validate it or check the XML syntax, we see there's no errors because that's not an XML syntax error. That's an error against our schema. It violates the rules of our schema, but it doesn't violate a rule of XML. So if we go back and we check, instead of check XML schema now, we check validate now, we can see that now we see an error because it's not validating against our schema, not against our custom rules or custom blueprint. So we can see XML validation error, line 13, position 18. Cat is not an integer data type. So in this case, it's pretty clear, saying cat's not an integer. So we have to change it back. And if we did plugins, validate now, we get no errors detected. So everything's good. If we want to make this error go away, we just go XML tools, check syntax now, and it'll clear away the errors for us. So the other type of errors this can detect are errors in our schema document. So for example, instead of XS:"integer, instead XS:"cats, which is an invalid type. Save that. And we'll go back to patientlist.xml, make sure that's saved. And we're going to go XML tools, validate now. And now we get XML validation error, line 7, position 56, undeclared XSD type. So this error is a little bit less helpful because it's not really telling us where in the XML schema document the error happened. But if you get an error here that says undeclared type, or it's saying that the error is happening right where you declared your schema, it likely means that there's an error with your schema document. Like we used a type that isn't valid. For example, cats is not a valid type in XML schemas. So this one's a bit more complicated because we have to go back into our document and try to figure out where the error is in our schema document. And again, it's not going to be a syntax error because we already checked for syntax errors. It's going to be some sort of logical error where we're not following the rules of XML schemas rather than the rules of XML syntax. Okay, so I'm going to fix this error by changing it back to integer. And one thing we'll note in the schema is that it says the patient element has to occur at least one time, but it can occur on any number of times. So we're going to see what happens when we violate this rule. But first, I should point something out. I just made a change to this schema file, change this back to integer, and I have to save. If we don't save, it's going to be checking against the version before we saved. So it's going to be looking at the actual file on our hard drive rather than what's currently open in Notepad++. So it's very important that you save before you validate so you know that it's actually checking against the most current version of the file. That's all saved. Make sure that's all saved. Now we're going to modify our XML document slightly just to remove all the patients. And this should be valid XML syntax. We go plugins, XML tools, check syntax. We get no errors because this doesn't violate the syntax rules of XML. We're allowed to have a root element with nothing in it. What it does violate are the rules of our schema. And once again, to check that, we have to instead select validate now instead of check XML schema now. We want to validate now. You can see that we get a new error saying patient list cannot be empty according to the schema. So we'll just put our patients back to fix that. So that's two examples of the kind of errors you can see. We could have errors that are coming from our XML document not following the schema, or we could have errors from our schema document not being valid, for example, creating or referencing types that don't exist. So it's important to note which type of error you're getting. If it's under this root document, referencing the schema, it's probably an error in the schema. If it's referencing a specific part of your XML document, like this error was, it means that it's probably something in your XML document not following your schema. It's a subtle difference, but it's really important because it'll tell you where to check to fix the errors. So So now at this point, if you're using Notepad++ with XML tools, you can skip to the end of this video right here. Otherwise, if you're going to be using the website xmlvalidation.com and not using Notepad++, I'm going to cover now how to do the same sort of things using that validation website. Once again, if you're using Notepad++, you can just skip to the end. So up on the screen right now, I have the patient list schema that we already saw, and we know at least has valid XML. And in another tab, I have our patient list XML file. And now we have this saying that it has a schema, and that schema is patient list schema.xsd. I'm going to go to the validation website, same URL, and we're going to start by uploading the XML document. So it's important when we want to test XML, if it conforms with the schema, that we start with the XML document and not with the schema. If we started with the schema, it would just tell us right away that it's valid XML. I'm going to start with patientlist.xml. And we should make sure that we click on validate against external XML source. So if we didn't do this, it would probably detect that it needs the schema because we have that line and it would work fine anyway. But we want to click this just to be sure, because if we didn't click this and we forgot to say that our XML document needs a schema, then it would just say no errors. And we might think, oh, it's working, when in reality we just forgot to check against the schema, and it's only checking XML syntax. So to say that we definitely want to check against a schema, we click this button and then click validate. Now it's not going to say errors or no errors right away. Instead, it's going to ask us to either paste a copy of the XML schema here or upload it. So again, we're going to browse. Remember, our schema was called patientlistschema.xsd. So we're going to upload that and click continue validation. In this case, we get no errors were found. So what that means is both there's no XML syntax errors in the schema or the XML document, and that our schema conforms, or rather our XML document conforms to our schema. So it's following all our rules. So maybe we want to see what it looks like if something goes wrong. So we'll go back to the first page, and we'll bring up our patient list and our schema. So let's make a minor error. So instead of doctor ID, maybe we will call this doc ID, and we'll create another error. Let's say take days, and we're going to move it out of medications. We're going to put it under birth date. So this would cause two issues. It means our XML document's not going to be conforming to our schema because it's called doctor ID instead of doc ID. And down here, the order is going to be wrong. So we're going to have days underneath the medication list, and there won't be a days inside the medication list. So that should cause actually quite a few errors because the medication is repeated in the file. So let's see what happens. And in this case, we'll try everything out with pasting instead of uploading. It's the same idea, but we'll just get will allow us to see both ways to work. I'm going to paste it here, and we're going to make sure we collect validate against an external schema. Validate. It's asking us for the schema, so we could also paste it. Make sure we copy the whole thing, paste it there, and continue validation. So in this case, the XML was valid, but now it's detecting some issues with the schema or the XML not conforming to the schema we made. So the first one is saying invalid content was found. So that's meaning it's not an XML syntax error, rather it's not valid content because it doesn't conform with our schema. Saying it found the element ID doctor ID, but it was expecting doc ID. Remember that's because in our schema, we changed it to say doc ID. As this error is occurring on line 13. So if we click here to jump down, we can see line 13 is up here, and indeed it does say doctor ID in the XML. The other issue it's found, it said invalid content was found, so that's a big hint that this is an issue with compliance with the schema. And it says it's starting with element days, and it says basically that one was expected. So we jump down to 19, it's up here. So the issue is that inside of medication, it ran into a days tag. But remember that change we made to the schema moved the days tag outside of medication, so it's expecting it after the medication list. but now it found it inside the medication list, so that doesn't conform. So we can easily fix that by just undoing the errors we made. Oops, I'm editing the XML document, add the schema. And once again, you can edit right on their website like this, but it's not something I normally recommend, just because you're not going to be saving it. You're not going to be able to get this back if you close your browser. So you should always be editing it in your actual Word or your text processor, or plain text processor. The other issue was Docker ID. So we can take another look at how we could cause issues. So for card number, let's try changing this to an integer. You remember there were dashes and letters in the card number. That's one of the reasons why we use string. So what would happen if we switched this to say that the data type has to be integer? So we're editing the schema right now. So now our schema would say that the card number has to be a whole number. That's not the case. So let's see what happens. Now we're getting some new errors. And these are errors specifically about data rather than elements. So it's saying it's not a valid value. So when we get errors like this saying it's not a valid value, that means the data is not conforming to the schema. So the schema validates both the data and the elements. So the first one's on line 9, and it says it's not a valid integer. And that was that first card number we saw, and that's obviously not a whole number. It's got dashes, it's got letters, and things like that. So how would you fix that? Well, it's easy. We just undo what we did. That's the XML document. Schema. And we switch that back to a string. And everything should validate. Yep, so this is what we want. So remember, this is just telling us now that XML syntax is valid and that it conforms with our schema. If we made issues writing our schema doesn't make sense, but our XML document conforms to it, that means we could still have sort of logic errors. So this is only going to be good as your schema is. If your schema allows everything, then it's not going to be very helpful. So just because you get no errors doesn't mean it's correct, but it's a good indication that you're on the right path. So make sure that whenever you make any changes at all, even if you're just changing a comment in your XML documents, you validate it against the schema again. So not just the syntax, but against the schema, especially right before you submit your assignment. So hopefully that gave you a good idea of how we write XML schemas and another example. If you're still a bit confused, I do recommend those W3 school tutorials, as well as going over those XML schema slides, and we have that step-by-step XML example on OWL, which again guides you through each step in a text-based format. So there's a lot of resources that you can review, and of course, if you're always any way confused or you have any questions, you can post on the OWL forums, you can attend a TA office hour, or you can always email me. So thank you for watching, and have a great day.